Alright, so in our last tutorial we implemented checking rows and columns in our Sudoku puzzle. Now in this tutorial we're going to work on our boxes. So another Sudoku rule is that the same number cannot appear in the same box more than once. So because there is a 1 here, for example, we know that there can't be a 1 in here, which we already know by our row trick. And there can't be a 1 down here, which we also know by our column trick. But additionally, not just those two numbers, but this number over here cannot be a 1, this number can't be a 1, and this one in the bottom corner cannot be a 1. So we're going to work on implementing that in this tutorial. So we need a box struct, which we've already started writing here. We're going to add a few things to it. So we're going to keep track of all the squares that are in the box. So that's going to be struct square star star. So it's an array of squares, and we'll just call it squares. And remember, we have to put this struct at the front, because if we just do struct star star, C won't know what square is. So we just tell it, well, it's a struct that's declared down here. Okay, so we're also going to keep track of how many numbers are in the box. So int numbers. And we're going to do an int possible, which we're going to do the same. If you remember from our last tutorial, we had this possible array and this solvable number, where basically we create this array, and I'm not going to go over it all again, but we talked about it in the last tutorial. And then we had this solvable that when it equals 1 for a square, we know that there's that square solvable. Well, if you think of it for a box, if there are 8 numbers in a box, then we know that the last remaining number is solvable. We can figure out what it is. So we're just going to keep track of that as well. So that gives us an int possible, that array down here, 9 numbers, and int solvable. So again, same idea. And that will be it for our struct. Okay, so now we need to create our box. So in setup puzzle, that's where we'll create it. So it's going to be box star star boxes. So it's going to be an array of boxes. And then to create it, we'll just do boxes equals create boxes. And this will be a function that we write. Okay, so let's create a new file, just like we did with square.c, but this one will be box.c. And we can save that. This is, of course, going to include our .h file, pound include sudoku.h, and then we'll write that function, create boxes. We'll return an int, and it won't take any arguments. Return 1. So here we'll just malloc everything. So we have box star star boxes. Oh, we'll also need some counter variables, so int x and y should work. And let's malloc those boxes. So boxes equals malloc size of box pointer. And there are 9 boxes in a Sudoku puzzle. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's that malloc, and then we need to malloc each individual box. So again, there are 9, so we'll loop through those. X equals 0, x is less than 9, x plus plus, and boxes x equals malloc size of box. Then we want to malloc our array of squares. If you remember in our Sudoku.h, we have this array of squares that just will be able to let us keep track of all the squares that are in the box. So boxes x squares equals malloc size of square pointer times 9, because there are 9 squares in a box. And then there are 0 numbers at the start. So boxes x numbers equals 0, and boxes x solvable, we'll start that at 9, just like we do with the square, and then every time we find a square that's been solved, we'll decrease it, and when that equals 1, we know that that remaining square is solvable. And then finally, we're going to initialize that possible array. So for y equals 0, y is less than 9, y plus plus, we will just say boxes x possible y is equal to 0, and that will initialize it. And then this shouldn't be in, this should be box star star, and we'll return boxes. Okay, let's add that to our .h. So we're gonna have a section for box functions. Box functions. Okay, so that should be good. So we're saving it in boxes. Okay, now. Okay, so what we want to do is, here we're kind of setting up our puzzle. So there's going to be some things that we want to do. We want to every time that we create a square, so down here we're mallocing each square. We want to add this square here to the box that it belongs to. Okay, and then also, if you remember, in our square function, we're also keeping track of which box it's in. So we want to both add this square to the box and add the box to the square, if that makes sense. So they both reference each other. Okay, so we can do that down here. We'll just get into it. Boxes. We're going to keep track of which box we're at. Okay, so like for here, this is box, well, it's box 1, but since arrays are 0 based, this is box 0, 1, 2, and then this will be 3, 4, 5, 6, 7, 8. Okay, so remember we have an array of 9 boxes in boxes here, but we want to keep track of which box we're adding to. So we're going to add an integer called current box. Okay, and it's going to start at 0. Okay, so for the first 3 numbers, because we go, this is the first number that we look at, and then we look at this number, and then we look at this number, that's box 0. Okay, so boxes current box square. Sorry, let me look at my .h here. Squares, and then we're to keep track of which square we're at, we're going to use that numbers. Okay, so remember we started that at 0, so again there will be 9 numbers. So boxes current boxes is going to be the index. I know this is kind of crazy, but so numbers. Okay, so that's our That's what we're using as our index for the array of squares, equals, and then it's this square here. Okay? So that's adding this square to that array. And then we need to increment the numbers because we've added a number. Okay, but we also want to add in our square which box it's in. We want to update that. So copy this, Sudoku ij box is equal to box's current box. Okay, so now the box points to the square and the square points to the box. And that all makes sense eventually. Okay, now what we want to do is we want to check and make sure that we're still in the current box. Remember this current box, it starts at 0 because it means that we're in this box, okay? But as soon as we get to here, we're into box 1, so we need to add to it. Okay, so how we're going to do that is, remember, we have j looping through the columns and I looping through the rows. Okay, so j is equal to 0, we're at this number. J is equal to 1, we're at this number. J is equal to 2, we're at this column. So when j is equal to 3, our current box goes from either 0 to 1, or 3 to 4, or 6 to 7. Okay, so we increment it when we hit j is equal to 2. Okay, so 0, 1, 2, we need to go to the next box in the row. So we're going to do an if statement here. We're going to say if j, remember that's our counter up here that's looping through the columns, if j is equal to 2, then current box goes up by 1. Okay. Now, what happens if we get to here? Okay, so if we get to here. Yeah, if we get to here, then what happens is, so this is j equals 0, 1, 2, we go to the next box. J is equal to 3, 4, 5, we go to the next box. So same thing, if j is equal to 5, we go to the next box. Okay? But then what happens when we get here? Well, we go back to box 0, right? So what actually happens is we go down 2 numbers when at the end of this loop, right? At the end of this loop, we go back to our box 0. So that means that we're at box 0, 1, 2, we go back to box 0. If we're at box 3, 4, 5, we go back to box 3. Hope that makes sense. So here, we just need to decrease our current box by 2. So that's going to be minus equal 2. So we're decreasing the current box kind of back to the start. Okay, does that make sense? But then there's a special case here where if j is equal to, if we get to row, this is row 1, row 2, row 3, row 0, row 1, row 2. Okay, at row 2, then we don't go, when we go here, this is box 2, we don't go back to box 0, so this minus 0 minus equal 2 isn't going to work because we actually want to go to box 3. So that's going to be a special case. We're going to say if I, which again is the counter for the row loop, if I is equal to 2, then current box is equal to 3. Okay, and likewise, I'm sure you can see what's coming here. If we get to row 2, 3, 4, 5, we don't want to go back to box 3, we want to go to box 6. Yeah, box 6, 7, 8. So if we get here, we want to go to this next box. So that's going to be if I is equal to 5, current box is equal to 6. Okay? So that will just keep track of which box we're at for this array of boxes. Okay, so that's pretty good. Now, so we're saving all this information, and then down here, so when we find out, this loop goes through our puzzle again, right? And it says, is this number not equal to 0? Basically, does it have a number? And so in this case, when there's a 1, we say, oh yes, there's a number here, therefore 1 can't go here, can't go here, can't go anywhere in, well, right now we're just doing rows and columns, okay? But we want to update our code so that it goes through every square in the box. Remember, in our box, we've saved which squares are in that box, okay? So we want to go through each of those squares and say 1 cannot go in here, 1 cannot go in here, cannot go in here. So yeah, we want to write an update boxes function. So it'll be the same thing, just specifically for the boxes. So right under update Sudoku, we'll just write update boxes. And it will take the same arguments. So the puzzle Sudoku, I, J. So let's write that in our boxes file. This will return an int update boxes. This will be square triple pointer Sudoku int row and int column. And let's add that to our .h before we forget. Save that. Okay, so this is going to look like we need a counter variable int x. And we're going to save the number that we found. So remember, we have either just solved the number or just found a number that was already there. And so now we're going to say, and all the other squares within that box, 1 can't go here, can't go there. So we're going to say what number that is, and we can just do that by doing Sudoku row and column. Sorry, int number equals Sudoku row column number. All right, and then we're also going to save which box we're working with. So box star box, and then box equals, again, the Sudoku row column box. So that will just make the typing a little simpler instead of always, using these. Okay, so a for loop, x is equal to 0, and here we're just going to loop through every square in the box, x plus plus, and we're going to say if box squares x, so the current square that we're looking, solvable, sorry, not solvable, possible number minus 1. Remember, we did this in the last tutorial. Number minus 1 is equal to 0. Then that means that we found a new number. We're one step closer to solving the square. So then what we do is we do box squares x solvable, and we decrease that, and then we set this to be equal to 1. So just in case that wasn't clear from the last tutorial, I'll try and explain it again. Each square has this array of numbers, and they all start out as zeros. And then when we find out, so for this one example down here, this is going to start. This 0 here is going to start with their possible array all set to 0. But then when we get to this 1, we're going to say, oh, this square is in the same box as this 1, therefore that square can't be a 1, and we're going to set that to 1. And then remember, it starts out with there's 9 zeros. When we get down to 1 0 and 8 nines, or 8 ones, then we know that that square is solvable. So just another trick of Sudoku that we're adding in. Okay, so box square is possible. Number minus 1 equals 1. And that's it, I think. I think that's it. So let's save that and let's run it. Now, when we were just using the rows and columns trick, we weren't actually solving any squares in our puzzle. But let's see if it's if we made any improvements there. Okay, so it makes with no errors. And yeah, we're actually seeing that there is improvement. So here, if you look at this square right here, there's no number. But down here, we've solved it. A 3 goes there. And let's see if we can figure out why. So 1 can't because it's in the same box. 2 can't because it's in the same column. So no 3s. 4 can't because it's in the same column. 5 can't. 6 can't. 7 can't because it's in the same row. 8 can't because it's in the same row and box. And 9 can't. So that's something that isn't actually even affected by the box. That's interesting. So that what we just added didn't really add anything to it. Huh. I'm wondering why it wasn't showing up. Oh, it was. No, it was. So that was solving. Yeah, so that doesn't change anything. So let's see if there's anything else that gets solved. I don't see anything. So one of the things that we can do is we only run this check puzzle once. Now, if let's say, for example, that 3 gets added in, well, that gives us more information about these and these. So sometimes we're gonna have to run this more than once. So let's just run it a second time, see if that changes anything. And you can see it has, because here we have a 6 and a 5 in this box. Now here we have 6, 4, 1. So slowly we're starting to solve it. And I don't think, oh, there's a 5 there too. And I don't think if we run it a third time it will change anything, but let's just see. Clear make. So I don't think it has, maybe it has, but there's still a lot of tricks that we need to add in to solve this puzzle. But we're much closer now than if you compare this to where we were before. It's, we've basically solved this entire row. Have we done it right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like it's working. We're moving closer, so that's good news. Let's actually just run this a bunch of times. Eventually we'll have this in a loop that just keeps running until it's either solved or determined to be unsolvable, but yeah, okay, so we're basically hitting the limit there. Yeah, anyways, we'll just keep adding tricks until we've got the entire puzzle solved.